So good morning, everyone. Well, what I will speak about today is about an alternative approach to problem types. This is in a sense, a provocative title, which I made on purpose because it's just to show an idea that it is alternative, complementary, however you want to say, to normal problem types. The idea is to have something which is less user-friendly, but also more powerful and more easier, let's say, to maintain and to extend from developers which have expertise on programming, but not in GiD. The people that are involved in this are, part of myself, Carlos Rossi, who did much of the JavaScript, which is under the hood, Ruben, who worked a lot on many of the different nodes that are shown, and Javi Garate, who did the GiD part. Well, what is the idea about this? In a traditional problem type, this is what we see. What we see when we load the Kratos problem type. Well, when you load something, then what you get is a complicated tree in which essentially guides the user through the definition of a lot of things. This mixes two things. It mixes the construction of the geometry, which is, let's say, the CAD-related part of GiD, and the prescription of boundary condition or a physical condition that are needed in order to solve the problem. The idea that we want to have is to try to split this, to have the part related to the modeling of the geometry done within GiD and all the other part to be put onto the developers in a way that it can be touched in a more flexible way, hopefully. And to this end, what we have is that we defined a special box, which was done by Javi Garate, that is this one. And that is something that does nothing else than writing geometrical information into a format that our code, the Kratos, can read. Here specifically, what we add is, for example, an inlet, an outlet, we have an object, and we have a volume. And what we are telling, we have a mesh, that in this case is very coarse, but it doesn't matter. But essentially, we want to tell that for example, every triangle in this is written, which is an element for us, is written in the group volume. In a group inside Kratos is called the submodel parts. We also want to have in this group volume the faces, although we may decide not to have them. There's no problem with that. And the nodes. And for all the groups, we are telling what kind of information need to belong to that or need to be written in the group. Well, this is, as you see, there is no physics at all. It is just a way of writing the geometrical information and the meshing information into our format. So when we give calculate, what we get is a simple file. And the simple file is this, which contains nothing else than the connectivity and the organization of the different geometrical entities into the submodel parts that are well, let's say the groups, the concept of groups inside Kratos. The idea is that, of course, we need something, and this something is everything about the physics, like what to do on the inlet, what to do on the outlet, and these sort of things. Well, so in order, we need to complete the geometrical information by something, and this something is done, as I will show, by a visual programming approach. So there is a library. We are using the Light Graph library, which is available with a very liberal license in the web, but we tailored it to our use. So that, for example, now we will use this in order to create the information that are needed in order to run a program. So, for example, and just to give an idea, to have something inside Kratos, we need to have a stage. This is the stage. It looks like this. For example, you will need some problem data, which may contain information about time or about these sort of things, or whatever, and then you need solver settings. Solver settings, for example, contains the data about the physical solver that is needed, that will be used under the hood while doing an analysis stage. Well, for example, what we can is that we can import a fluid solver, and I mean the idea is that this information, so everything that is prescribed in this box, which for example contains a lot of different defaults, will be used to fill these parts, or this what is needed of this of the analysis stage, and then one can constructively do things. For example, one needs to define a linear solver settings, and well, one may define the solver settings like this, okay, also with a lot of parameters, also with some possibility to choose and to define this like this, okay. Now, what is the connection to the geometry? The connection to the geometry is that at a certain point, when we go and construct all the items in this box, what we need to read the MBPA that the GiD brought to us, which is this, and then we will have to tell, for example, that the volume of these, sorry, well, it is not here, it doesn't really matter, but it is here. It is here. Then the volume part that we defined, that's the name of the group inside GiD, that goes to the volume model part within the fluid domain. And we can do all of this for all of the boxes that are contained here. For example, one may define an output process, and this output process will have a lot of information about, for example, what is needed, what is the sort of output that we need. In this case, for example, velocity and pressure, or whatever. Let's keep it short. At the very end, the goal of all of this is to create the configuration file for Kratos in the specific case. So what we will want to do is to eventually download this. This will create a file that we can download. So constructively, this is like a program, a workflow of a program that runs into this. So if you run this and you download that, well, you will get one file that's formatted, that contains the information needed for this. Okay, and of course, if I change something in here, the corresponding entry will change in this file. Well, in a sense, this is all what I wanted to do. I mean, of course, this is very. There is much more than this about what can be done. For example, we can select some of those boxes and import or export them. Let's just see something that I saved before, but I don't know, one can, for example, in this case, it is just the same thing, but we could import something that was done before. Okay. Well, now there's a lot of clutter because, of course, I had the bad idea of importing everything on the same block. But of course, if I redo it on a clean slate, well, I think it's pretty obvious, but I can get something like this, okay? And you can have subgraphs, which contain some more things, or you can organize this the way you like in order to avoid cluttering this thing. Nothing. My message is this is useful for us. It may also be useful for other people because it is relatively easy to maintain those boxes. And because in a way one can construct a different workflow visually in a way that is, I think, quite user-friendly. The idea is not mine. This is being used in many different contexts. In particular, the idea was given to me by some people working in Munich that were using the Rhino and in particular the plugin Grasshopper. And well, nothing. This is something that I hope that may eventually work together with GiD, and that I thought that could be useful, maybe to achieve some sort of integration. Thank you for listening. Bye-bye.